Hi everyone. Welcome to day two of our pre-Devfest series. Tonight we'll be having another catch, who is a seasoned software engineer with a passion for artificial intelligence. He'll be leading us through the cloud session. Uh, Back to you.
Thank you. Hello, everyone. As Eugene has said, my name is Arnold Akach, and today we will be talking about cloud security. We are going to showcase how we're going to use AI to strengthen cloud security for cloud security protection. Right. Just a minute. Right. Thank you. Um, So we're going to start with for this session. We're going to have a few main points where we're going to first we're going to talk about the importance of AI in cybersecurity, where we're going to look at why we should use artificial intelligence as it is in cybersecurity and why we should use it. Then we're going to look at cloud computing and how we can use AI within cloud computing. And after that, we're going to look at machine learning and how we can use machine learning within cloud security, machine learning algorithms within cloud security. After which, I will show a short demo. Then, after that, we're going to discuss the next steps of how this is going to impact cloud security futures. Right. So, first, let's look at the importance of AI in cybersecurity. And sometimes we ask ourselves, like, AI, is it too much or is it just enough? Like, we're going into a world where AI is going to be the inevitable future, where AI is going to be almost everywhere. And in as much as we're using AI to kind of guarantee our lives, our how we can make our work easier, we also need to look at, is it really necessary to use AI at this specific point? Is it really necessary to use AI at for this particular function? And that's where we come in with the importance of AI in cybersecurity. Remember, cybersecurity is all about the protection of um, is the protection of like the practice of protecting systems, networks, and programs from digital attacks, like cyber attacks. So when we look at it like that, AI can kind of play an important role in cybersecurity. Like, it can enable machines to perform tasks that normally require human technology, such as making decisions, recognizing human speech, and translating visual elements and languages into something that can be understood by a computer. Um, when we're talking about cybersecurity, we look at how threats, cyber threats have been evolving throughout the years. And without a doubt, they have been evolving. We just don't know it. So when we talk about cybersecurity, we look at how exactly are we going to use AI to try and help us deal with these ever evolving cyber threats. For example, traditional right here, traditional cybersecurity protocols are not quite adaptive to modern and evolving cyber threats. Such threats, like polymorphic malware, are programmed to repeatedly change what they look like, their signature files, through new decryption routines. So you get traditional cybersecurity protocols won't be able to identify malware that has evolved into something else. Even though malware is still malware, like, malware can't be successful without exhibiting malicious intent. Sometimes the malware can evolve too practically to make it invisible to traditional cybersecurity protocols. And that is why we are looking at seeing, we are looking to introduce AI. That's why it is necessary to introduce AI into cybersecurity, because with it, AI, with how certain algorithms are, how they work, we can be able to identify this polymorphic malware, these viruses that keep on modifying how they look. We can be able to track their tendencies. We can be able to identify their patterns, and with the necessary measures taken, we can also be able to prevent, rather stop these malicious programs from taking their course. So AI uses data to comprehend context and determine how to respond to different stimuli and situations. You'll get in a situation where data can be fed to an online server through injection. AI can be able to identify and comprehend what is happening, and then it will be able to respond to that in the context of injection. The monitoring, detection, and response of to cyber threats can be done in real time with AI, which is something that we are looking to have in the near future, because analysts cannot sit down and view everything all at once and catch everything that is happening within a specific network all at once. They are bound to human error, which is sometimes they're going to miss um, what something, there could be something minute in the network server that might cause a disruption, and they might miss it. And that's why AI's monitoring, detection, and response algorithms can be helpful in cybersecurity. We're looking at it also as how machine learning can help the security analysts to level the battlefield. Like, if we consider cybersecurity as a large, let's say, battlefield where there's the opposition and then there's the defense. If we consider cybersecurity as such a space where the attackers and the hackers are the ones on the offensive, we can use AI to kind of levelize the ground, because with each attack, hackers tend to upgrade, let's say, improve on their tactics, on how they're going to do something, how they create the malicious malware. They can even be able to make polymorphic malware. So we can use AI to kind of level the ground, so that AI can provide insights based on rapid analysis and security alerts. It can even be able to point out on false positives or negatives and be able to identify between the two to help with ensuring that the right track is followed, right? Yeah, so with that, we can see here, we can talk about AI and cloud computing. First, if we want to know, cloud computing is just like availability of computing services through the internet. Basically, like working remotely, uploading and downloading data. That is basically cloud computing. So, what is AI and in cloud computing? AI in cloud computing basically is just it enables a shift from reactive operations to the proactive operations, which enhance system reliability, they enhance resource utilization and cost efficiency. In the case where we would need human interaction to work on a certain piece of data to facilitate transfer of data from one point in a cloud computing to another, AI can be able to kind of streamline how it goes, so that it's just simpler, it doesn't take a lot of time, and it reduces of the cost on the operator. So key applications of AI in cloud computing include they are like predictive analysis, which is important for dynamic scaling. You have anomaly detection for identifying threats and bottlenecks in, let's say, a network or network traffic. Real-time resource optimization and AI-driven security tools, which ensure data protection and compliance. So AI can also be used in computing, in cloud computing, for tasks such as workload optimization, where it can just reduce the workload that would normally be on a system analyst who's operating the cloud computer, who's, sorry, not operating, managing the cloud. It can also be useful in predictive maintenance, where if the system is bound to, you know, like a failure or a threat or problem, AI can kind of use its predictive algorithms to tell when these might happen, to help with finding a solution so that it reduces the downtime of the server or of the cloud. It can also be used for cybersecurity, security, to protect the cloud, and basically just UI, how the UI interacts with the users and the and the dynamic nature of the cloud security demands constant adaptation, since it since as AI, as cybersecurity defenses strengthen, so do cyber threats. And therefore, as you can see there, AI enables a shift from reactive to proactive operations to enhance system reliability, resource utilization, and cost efficiency. And now we could look at how machine learning can be used in cloud security. First of all, cloud security is just basically that's security involving the cloud, how we can protect the cloud from cyber threats, from anything that is going on in the background that we cannot see, And as you see here, cloud security is like a battlefield where attackers constantly improve their strategies. And as they improve their strategies, we should also be able to improve our strategies. How can we do that? We can use artificial intelligence, machine learning algorithms to kind of levelize the playing field at which we are in. We can use certain machine learning algorithms because the dynamic nature of cloud environments, combined with the complexity of cyber threats, necessitates innovative and adaptive security measures, which often human interaction might fail to achieve. So the incorporation of machine learning and cloud security is motivated by its ability to analyze vast data sets, identify patterns, and adapt into emerging threats in real time. Now, cloud security demands a multifaceted strategy, and AI technologies can probe vulnerabilities using real-world attack methods, breach detection methods, and provide robust defensive measures information. There we have some three steps that machine learning can be able to provide within cloud security. We have, we have preemptive solving, which is basically just making the AI algorithm proactively run a hacker simulation test to kind of test the latest tactics that hackers can be using to go after cloud environments. Think of it as having AI hack you or your cloud network. But now, instead of hacking you for malicious intent, it is hacking with the purpose to find any vulnerabilities that can be that exist within the system or the network. So the AI will try to exploit those weaknesses, pinpoint them, where it can also help with providing the required solution to fixing it. We also have detection with precision, where AI uses machine learning and pattern recognition to, it can use AI, it can use machine learning and pattern recognition to analyze all the network traffic within a network and user activity data within the cloud environment to identify anything out of the ordinary that an analyst could easily miss. Let's say, for example, if the network traffic consists of a humongous data set, it's going to be impossible for a system analyst to capture every single anomaly that occurs within that specific data set, even if it's regarded as a small data set, maybe of like 100,000. It's going to be impossible for any human analyst to get every single problem that might be there, every single anomaly. Therefore, we can use AI's pattern recognition to analyze such network traffic and user data activity to identify anything out of the ordinary, anything that looks amiss. And the final step is to use swift and effective defense, where AI can not only be used to detect cyber threats, but also start initiating defense actions to contain and neutralize these threats. These can be isolating the affected areas, like putting them on lockdown, deploying countermeasures and to stop the attack as it ensues, and even automatically patching the vulnerabilities that have been found by the AI algorithm. AI can also step in to limit the damage and ensure the core operations in the cloud run with as little disruption as possible. As you can see here, the incorporation of machine learning and deep learning algorithms in cloud security is motivated by its ability to analyze vast data sets, identify patterns, and adapt to emerging threats in real time. And that is the main thing we're looking at while we're incorporating AI, because the network traffic is increasing in size. It keeps on growing with every minute because someone is accessing the cloud at one point, another one is accessing the cloud. And pretty soon, cloud computing is going to be the thing where we'll have businesses and organizations set up cloud environments for their employees. They're going to have to work remotely. You do certain work, you upload it to the cloud where every single person in that server can be able to access it. So when we look at machine learning and deep learning, we can see unsupervised machine learning models such as isolation forest can be significantly used in anomaly detection within the cloud environments. It can identify abnormal patterns and behaviors and signal these behaviors as potential cybersecurity risks. It can also enable real-time incident response mechanisms to ensure security risks within the cloud environments are contained. Now, machine learning also integrates continual learning mechanisms in machine learning models, which exhibit adaptive security capabilities. Now, when you look at deep learning, it's a subset of machine learning. And this deep learning can be used together with machine learning because deep learning has sort of neural networks, which can be important to simulate complex decision making. It can be used to simulate complex decision making capabilities that a human would normally use to make for the AI algorithm. So if in case we have let's say our machine learning algorithm discovers an anomaly, like increased network traffic data to a specific IP address, it can flag this as an anomaly, and with using the neural networks, it can make a decision to either stop the traffic flowing to this the destination, or to kind of reduce the flow and observe what is being shared through this. If it's something that can raise security issues, the transaction can be stopped by the AI. So in this section, we're going to be looking at TensorFlow, where we're going to see how we can use it for anomaly detection. Now, there are various tools by Google which you can use to kind of enhance cloud security in your cloud servers. We have the Google Cloud Security Command Centers, which demonstrates real-time threat detection using built-in machine learning models to identify unusual activity and provide actionable insights. We also have Google Chronicle, which it uses machine learning for automated threat analysis and enables faster response times to security risks. We also have Google Cloud Armor, which uses pre-built AI models for threat detection and automates security tasks like malware detection, utilizing AI Hub to show how developers can rapidly deploy these solutions. So Google Cloud Armor generally provides DDoS attack protection and application security using Google's global infrastructure. For TensorFlow, TensorFlow showcases how you can build a TensorFlow model that identifies malicious behavior or anomalies in network traffic, and this can be used to develop deep learning models to predict and prevent cybersecurity threats. So allow me to take you to a Colab notebook where I can show you how we can practically use we can practically use AI for cloud security. Right. So as we have here, this is a simple AI model that can be used to identify anomaly, any kind of anomaly within a given network dataset. So first, what we're gonna do here is we're going to import our Python libraries, which we're importing TensorFlow, importing pandas to use for our data later, and we're also importing isolation forest. Now, isolation forest is a model used in machine learning that can be able to detect and identify anomalies, and that's why we use it here. So if I run this, it is going to import all the libraries that we have listed right here. Right. So all our libraries have been imported. Now, the dataset that I used was from Kaggle, but it was a bit large, so I had to download it locally to my computer. So we use this Python code, the Colab code, to upload our dataset, which is going to be here. Right. Now it might take a while, but once it is done, the next line is going to read the data from our dataset right here, which is called the synthetic network traffic dataset, and is going to put it all in a variable called data, where after that we're going to read. This one is just this is not really a necessary bit, it's just for future reference, where we can just add extra information to our dataset. After adding that, we come here where we have to oversample the anomaly class to balance the class distribution, because you might find in the dataset that we use, the data containing anomalies might be significantly overshadowed by the normal data, which doesn't contain anomalies. And to prevent this data from being ignored by the model, we're going to oversample it to balance, so as to balance the information. Then after that, we're going to split the dataset into features and labels. After splitting the dataset, we're going to divide the data within the dataset into the training data, the validation data, and the testing set data, where we can have here X train, X temp, Y train, Y temp, which is the train test split. And here we can also have the train test split. Sorry. So basically what we're doing is dividing the data which we have into training data, into validation data, and the testing data. And as we wait, I can show you exactly how large our data set is, the data set we are using. Sorry, I apologize. I should have uploaded the data set a while back. It's going to take some time. So after splitting the dataset, we're going to standardize the features of the dataset, where we can look at the data that is coming in through our values, and we can standardize them into something that kind of how can I explain it? Basically, we're just putting them towards a standard scale where we can have like a level ground on how we can identify the anomalies. Then after that, we create the isolation forest model, and we fit it into a system where this, remember, this is the machine learning module that kind of identifies anomalies in datasets. After we create and fit it, right, let me try running the rest. like this one. Yeah, I think it's gonna need the data set. We use the isolation forest model to predict anomalies within our data set. And then after we do that, we create the deep learning model where we can use it for anomaly detection. Once we've done that, we compile the model and train the model with our training data from the data set. Then evaluate the model with the tests with the test data that we had split from our data set. Now, as you can see here, I had run the test earlier before this, and as you can see here, the model iterates 5 times through the data set. As you can see here, an epoch represents an iteration. So it iterates 5 times because we have set it right here to iterate 5 times. It iterates 5 times through the data set, the test data, to find the anomalies within it. After that, we create a confusion matrix where we can be able to show and see exactly a matrix basically of the numbers that we have, the normal data, the anomalies identified within the data set. It will show up as a matrix. Then after that, we use this code to visualize our anomaly versus normal data through a ROC curve. And after that, we will visualize the confusion matrix and finally display our classification report. Now, it's taking a while to upload the data model. It might take a while as we wait for the data set to be uploaded. I can open the floor for any questions.
I don't think we have any questions so far on the chat.
Learn how to crack password in a safe file. Devendra, is it for malicious intent? Because if it is for malicious intent, then that is kind of illegal, you know. Yes, it is possible to crack a password, but because it's kind of not legal, I'm not going to share it here.
Arnold, I had a question.
Okay.
Like, how can we enhance data? I don't know how to phrase it exactly, but how can let me think about how to phrase it. I think I just wanted to ask how can, like, what are the risks of using AI to automate cloud security?
Right. Um, well, AI is kind of an unpredictable scene. When we look at AI, we need to understand how exactly it makes the decisions it makes, how it works. So the risk of using AI in cloud security can, for one, be you don't know why it has made the decision it has made. Let's say, for example, it runs through the network traffic data, and it finds an anomaly within the the traffic, but the AI decides to shut down the entire network. you know that can be considered a problem because service delivery is going to be slowed down. So, and without knowing why exactly the AI did this, I'd say that is a risk. That is one of the risks that we can have with using AI, where basically it's called the black box problem, where um, how the decisions of the AI model is made are not exactly presented to the engineers who are behind the AI algorithm. And that is the risk I can come up with right now. One of the risks. I think it's major.
But then how do Paul when it comes to compromised credentials? How would you detect that? Because let's say I've just forgotten my password and I've tried like 3, 5 times.
Right now,
But then
that
how
that might also be a problem because if you look at a situation like that where you've forgotten your password and you're entering it a lot of times, that's why normally it's advised that passwords give you a certain limit to which you can enter the wrong password before you are actually locked out of your account. If we use AI to kind of detect such a situation, it can be predicted as someone with malicious intent is trying to crack your password by constantly imputing wrong passwords with the goal of getting the correct one. So that can also be predicted as such, and can also prompt the AI to enact on it. Let's say by kind of locking your account by securing it, or isolating the specific um, port to which your network is trying to connect to the server from. And at that point where it can allow analysts to identify what the problem might be. That's why in cybersecurity, we kind of consider how security can be done from both the user side and the the operator side. Where, let's say, you've forgotten your password, you might have to click the forgot password link, or maybe try and get someone from the site you're trying to access to help you gain back access. If we use AI in such a situation, it might predict that this is someone trying to get into this network through this account, and it's going to stop the transaction, because the AI is set there to protect the cloud. It's going to see this as a threat, and it might try to stop this said threat. So there's no definite way of showing how it can identify that this is me trying to log into my account. I've just forgotten my password. It will still see that as a security risk and try to act to defend it.
Lastly, add to us. So let's say, for example, within cloud infrastructure, how would it identify insider threats, or would it really identify insider threats within a cloud infrastructure?
It might be possible because basically when you look at threats, any kind of security threat that happens, it's not going to be possible to succeed without showing any form of malicious intent. So if at all there is any kind of insider threats that might occur, then the AI algorithm model can be trained to also analyze data from within. It can also be trained to analyze the data that also comes from within and check it for any kind of anomaly, because there's definitely going to be a spike with network traffic if at all it's an insider threat. There's going to be malicious intent that will help the AI identify that this is malicious activity coming from within. It is going to halt the process trying to create the threat, and it's going to it can advise the analysts and the cybersecurity personnel to try and find what is going on within this within the system. Right. As this one is trying to load, let me try and share some other data set where we kind of made a mock-up data set, a very small one, to show how our AI can be able to identify. Right. So here in this model, what we are going to do, we are going to generate random and synthetic normal data and anomaly data. Then we can combine the data, both of them, into X and Y, scale the data, and then split it into training and testing data. So if I run this, it's for loading and pre-processing the data that we are going to use. If I run this, oh, right, sorry, I forgot to run this. So first we start by importing the Python libraries. I have forgotten to run it. Then after that we can use it to load and pre-process our data. Then after that we can define the autoencoder model. Like, right, for this one we're not going to be using the isolation forest model. Isolation forest, maybe if once the data set on the other model runs, the other notebook runs, I will be able to show it. So right here we have some data that we create a model which is going to help us identify anomalies within our data that we have generated. Then here we are going to run the autoencoder on the normal data. Oh, sorry, sorry. Let me change this one to 15. Right. So we are going to run the autoencoder on the normal data without the anomalies to train it to be able to identify. Then after that, we run the autoencoder on the test data right here, where it's going to be for anomaly detection. And finally, we can run and evaluate our test data here. So right here, as you can see, this recall right here, this precision shows us how precise our AI model is going to be with identifying the data. So at 0.99, the model is able to identify that almost the entire data set is normal. It has no anomaly. And right here shows the anomaly that we can get within the data. If we look at our FI score here, this shows us how the model has identified the the anomalies. Now, this is not a very clear explanation of what I was saying. The other notebook has a better explanation of what I'm trying to say. But the F1 score right here shows that right here on the first test, our data is kind of normal. And within the second test, there is significant um, appearance of anomalies within the data set that we created. Um, the rest of this shows the accuracy of the model within it, which is 0.99 of finding anomalies within the given data set that we generated. Right, so that's about it. Once the data set loads, I will be able to show you exactly how we can use forest model to isolate these anomalies. All right, so unfortunately, the dataset is a little bit too large to load it onto the model, but I will make the GitHub repository available where you can find the data itself and train the model to fit your exact needs. We can use this kind of model if, let's say, for example, you want to create your own small cloud environment. You can use this model to try and test for anomalies. It works for smaller data where, let's say, your data isn't exceeding like 100,000, or let's say 1 million, let's say 1 million. It's not exceeding the size of 1 million data cells. It can be useful for smaller businesses, for for your personal environment, where in case you have a situation where someone might try to access data that you have, your private data. This AI model with TensorFlow specifically can be used to identify such anomalies and to some extent stop traffic flow to this exact anomaly where the destination is coming from. The source of this anomaly is coming from. Right. With that, I have been Arnold Okach. Thank you very much for your time.
Thanks for the insightful session, Arnold. I don't think we have any questions on the chat. So let's till we meet again, I'd like to ask our viewers to tune in for tomorrow's session, and cheers. Have a good night.